Hi, Chris Good here, and we're going to continue with the Week 7 Essentials video lecture, and this one's on alcohol. We already had one presentation in class on alcohol, but I'm just going to extend on some of the points that were brought up there. When we say alcohol, and we're talking about drugs, we're talking about one particular kind of alcohol, and that is ethanol, and it's shown in the lower right-hand corner of your screen. It looks like that. There's two carbon atoms, one surrounded by 3 hydrogens, the other by 2 hydrogens and a hydroxyl group, the OH group, and that is ethanol. There are other types of alcohols that we don't drink, that we don't ingest, like methanol, which only has just the right-hand part of that molecule and other hydrogen instead of a carbon. And propanol is another one. There's hexanol and pentanol, and there's lots of different types of alcohol. Ethanol, this one with just those 2 carbons, is the one that we drink. And we get alcohol through the process of fermentation. It is the cheapest, easiest way to get alcohol, and it's the conversion to alcohol from sugar. And yeasts do this automatically. It's the byproduct of them consuming the sugar, and that forms the basis of pretty much all the alcoholic beverages that we drink. In the presence of any kind of sugar, yeasts will make alcohol. You can make alcohol from starch sources, right, that you see in cereal grains, but first you have to start the conversion process to sugar by malting them. That means allowing these grains to germinate a little bit. That activates enzymes that converts the starch in the grain to sugar that the yeast, in the presence of that sugar, can start to ferment. Now, yeasts will keep making alcohol until it kills them, and that happens at about a concentration of 15%. So in a solution that reaches 15% alcohol, the yeast dies and fermentation stops. But we can further increase the concentration of alcohol in a solution by distillation. Distillation means that we're going to heat a solution with alcohol in it until it evaporates, and we condense alcohol vapors and then collect that alcohol separately from the solvent that it's in, mainly water, and that produces beverages with alcohol content higher than 15%. And this has been going on for thousands of years. Distillation was started in Arabia, spread to Europe around the 10th century. We started it here. By the end of the 18th century, we were doing sort of large-scale distilleries. And distilled alcohol content is measured in proof. It's twice the percentage of the alcohol by weight. So a 90 proof whiskey has a concentration of 45% alcohol. We're going to talk about some just regular fermentation products like beer and wine. We'll also talk about some distilled products like the whiskeys and vodka and things like that. Let's start with beer. Beer is made by adding barley malt. Barley is the grain, and remember, malted barley is barley that's been allowed to sprout just to begin the germination process, and then it's shut down by blasting hot air on it. So we've activated the enzymes. They're converting the starch in the barley grain to sugar, and then you add yeast to convert that sugar into alcohol in a solution. Beer is flavored with a flowering plant called hops, and if you've had like an ale, like a pale ale that has a very flowery, floral sort of flavor to it, those are the hops that you're tasting. There's a particular type of beer called a lager. Most of the beer that we drink in the United States, like Budweiser and Miller beer and things like that, are lagers. They use a type of yeast that goes down to the bottom of the mash, which is the barley mixed with the yeast to ferment. Ale uses a yeast that ferments on the top of the solution. It has a warmer fermentation temperature. You get more of a malty and hoppy taste to the ale. You can age a lager a little bit longer and get what's called a malt liquor. Lighter beer is light beer from Miller is fermented for a longer period of time at a cooler temperature, so you get more sugar converted to alcohol, and then it's watered down, and then you get, as a result, a beverage with similar alcohol content but less sugar. So more of the sugar in the mash is used up, so it's less sugar, more alcohol, but you dilute it down until the alcohol content's similar to those beers that are not light beers. So you have fewer calories. Wine, of course, everybody knows, the source of sugar for the yeasts in wine is from grapes. And it's the type of grape that determines what the flavor is, what the color of the wine is, whether it's a dry wine that has more alcohol or a sweet wine that has more sugar and less alcohol. The process that is used can determine whether it's a sparkling wine like a champagne or a flat wine. There are wines that are fortified that have distilled spirits added to them to bring up the alcohol closer to 20%, but the natural wine process tops out just below 15%. And a lot of wines that you see are between 10 and let's say 14% alcohol by volume. There are lots of different types of wines. They're produced all over the world, including some here in Georgia, and the differences between them depend on the type of grape that's grown, the place that it's grown, the weather that year, and there are lots of different varieties. Okay, distilled spirits, there's a couple different types. Let's talk about grain neutral spirits. So this is a clear, tasteless, nearly pure alcohol, close to 100%, about 95% alcohol that we produce by distillation. You can use this in a chemistry lab. You can use it to add to gasoline. You can use it as a solvent. It's also the exact same alcohol that's used to make various beverages. So when you dilute grain neutral spirits down to about 30 to 40% alcohol and flavor it with juniper berries, that's what gin is. Vodka is the same thing. It's nearly 100 proof grain neutral alcohol that's been diluted with water down to about 40 to 45% alcohol. So these products are diluted nearly pure alcohol that are clear because they don't have a lot of these byproducts of the fermentation process that we call congeners. And it's the congeners that give the color and the unique flavor and character to those brown liquors like whiskey. Let me go back one slide. You can make vodka out of anything. You can make it out of potatoes. You can make it out of grains. You can make it out of any sugar source, and you distill that fermentation product from whatever the sugar source was up until it's close to 100% alcohol, and then you dilute it back down to around 40%, between 40 and 45%. Okay, so whiskey has to be made from malted barley, and there's an early U.S. distiller from Bourbon County, Kentucky, that gave that beverage its name. It's distilled to a lower proof, around 160, which would be 80% alcohol, and so it has more congeners and some of the flavor from the grain left over. And you can have lots of different types of whiskeys dependent on the grain that was used in the fermentation process. So there's whiskey made from rye, there's whiskey made from corn, that's what bourbon is, and then there are blends of whiskey from different sources, and they're usually aged for at least 2 years. There are a lot of whiskeys that are aged for much, much longer than that. Then there are the Scotch whiskeys that are made from specific types of malted barley under specific conditions, and just a lot of variety there. But it's those congeners, it's those byproducts of the fermentation process that really give whiskeys their brownish color. Other types of distilled spirits, there are liqueurs or cordials. These usually have an alcohol content from 20 to 25%. These are ones that are like, creme de menthe or, Bailey's or something like that. And they were originally made from brandy, which is a type of distilled wine that's mixed with flavorings from herbs or berries or nuts. But now we usually just make them with pure alcohol and then dilute it down to the concentration of alcohol that we want. Alcohol was illegal in the United States. Individual states started prohibiting alcohol in about 1851, and by 1917, 64% of Americans could not buy alcohol legally where they lived. And these laws were influenced by a lot of different factors, including class and ethnicity and religion and politics. But even in these dry counties, people still drank illegally in these private clubs, these speakeasies, and legally you could get alcohol. And remember, these patent medicines were mostly alcohol. They had other drugs dissolved in them as well. At the federal level, it was the 18th Amendment to the U.S. Constitution that banned the sale of alcohol, and that started in January 1919, and the following year, Prohibition went into effect. So they ratified the amendment one year. 1920 went into effect, and for a dozen years, people continued to buy and sell alcohol illegally, and enforcing this was very difficult. So organized crime became even more organized, even more profitable, and although reported alcohol dependence and alcohol-related deaths declined, certainly lawlessness increased, and probably there were still some deaths related to alcohol that weren't reported because it was now illegal to do. So these are pictures from the 1920s during Prohibition, where these folks are busting up illegal alcohol distribution and sale operations. Eventually, Prohibition was repealed, partly because of widespread disrespect for these laws encouraged this general sense of lawlessness. People weren't following this law, and perhaps they weren't following other laws. Alcohol taxes had been a big source of revenue, so they weren't getting those taxes anymore. That certainly was another factor. Anyway, in 1933, the 21st Amendment was ratified, and that repealed Prohibition. After that, per capita sales and consumption increased slowly until just after World War II, and then they came back to pre-Prohibition levels, and so people were drinking as much as they ever did. Let's talk a little bit about alcohol pharmacology. Although some alcohol is absorbed in the stomach lining, almost all of the absorption of alcohol takes place in the small intestine, like other orally administered drugs. If there is food and water in the stomach, then that slows down absorption a little bit. But carbonated beverages speed it up. It's the carbon dioxide that increases the absorption of alcohol. We measure blood alcohol concentration as the percent of grams in 100 milliliters of blood as distributed evenly throughout body tissues, and so, but it's less distributed in fat, so that somebody who's leaner has a lower blood alcohol content than a fatter person. The liver can metabolize about 0.25 ounces, a quarter of an ounce of pure alcohol every hour. So if your rate of drinking is equal to the rate of metabolism, then your blood alcohol content will concentration will remain stable. However, if you exceed the metabolism rate, it will increase. A standard drink has about half an ounce of pure alcohol, so it should take about, well, if it's half an ounce and it's a quarter of an ounce an hour, then it should take a couple hours to completely metabolize 1 half ounce or 1 serving of alcohol. So half an ounce of pure alcohol is the same that's in an ounce of 100 proof liquor, 4 ounces of wine, or 12 ounces of beer. That's 12 ounces of beer that's at around 4%. Alcohol metabolism. So about 2% of alcohol is excreted unchanged, and about 90% is metabolized in the liver, and it goes through this process. There's 2 critical enzymes in alcohol metabolism. One is alcohol dehydrogenase. This converts alcohol to a compound called acetaldehyde. The second enzyme is aldehyde dehydrogenase, and it converts acetaldehyde to acetic acid. Now, if you don't have enough of the second enzyme, then it's not metabolizing the acetaldehyde, and it can build up to toxic amounts and make you feel pretty sick. In fact, it's antabuse that interferes with this enzyme, so that you get a buildup of this second metabolite, this first metabolite of alcohol, acetaldehyde, and it can bring on some pretty nasty symptoms. So This is used to teach people not to drink, right? Because if you are taking this medication, Antabuse, and you do end up drinking alcohol, it has a pretty nasty reaction. There's nothing really that you can do to speed up metabolism of alcohol. Working out won't do it. Coffee, other strategies won't do it. The liver, over a long term, will respond to chronic intake of alcohol by increasing the availability of these enzymes, and that's what explains the ability of heavy users to consume, vast quantities of alcohol and how they're able to tolerate it. Of course, we know alcohol acts as a central nervous system depressant. It is the world's most popular depressant drug. It was even used as an anesthetic until better anesthetics came along around the 19th century. Although a lot of the mechanisms of alcohol are pretty difficult to pin down, we do know that it has at least one mechanism of action that's similar to that of barbiturates and benzodiazepines. It enhances the inhibitory effect of GABA at the GABA-A receptor. At higher doses, it can also block the effects of glutamate by blocking a certain type of glutamate receptor. But it has other effects on dopaminergic, serotonergic, and cholinergic neurons. So if we go back to the GABA receptor, we do see a site for barbiturates and benzodiazepines. Alcohol has a similar effect to these drugs by sort of priming this receptor so that when GABA does bind to it, it's more efficient, and so it increases the inhibitory effect of GABA binding at its binding site. Let's look at some of the behavioral effects of alcohol. As blood alcohol concentration increases, you get more and more of these effects in more and more people. The LD50 down there at the bottom is about 0.4%, that's 0.4% by mass in 100 milliliters of blood. And by the time you get to 0.1 or so, you've impaired your motor function enough to impair your ability to operate heavy machinery, including cars. 0.08 is now the national blood alcohol concentration legal limit for driving. Men are more likely than women to be involved in alcohol-related fatal crashes, but anybody who drinks and drives is a potential threat. It's not just problem drinkers, so it's not just alcoholics who drive while impaired. Don't believe anybody who says that they drive better when they have had a few drinks because they pay more attention. It's just not the case. A little bit of alcohol impairs your ability to drive a little bit, and it goes up from there. Current efforts are to keep repeat offenders off the road by suspending their license, and publicity to spread the word about the dangers of drinking and driving. Also, younger drinkers are targeted for special prevention efforts. If you've ever had too much to drink, then you may have suffered a hangover. The symptoms are pretty easy to recognize: upset stomach, fatigue, headache, depression, just a general sick feeling of general malaise. We don't completely understand what's causing the hangover, but some possible causes include withdrawal from alcohol, congeners, which are those toxic byproducts of the fermentation process, could be to blame. Certainly dehydration is the key, although rehydration doesn't always cure the hangover. Interfering with the body's blood sugar levels, or perhaps the accumulation of acetaldehyde that the liver hasn't managed to dispense with yet. Really, we haven't come up with a way to cure the hangover. Not to drink so much. That's really the only way to avoid it. Drinking more alcohol might make you feel better in the short term, but eventually you will pay for curing your hangover with more alcohol. We talked briefly about fetal alcohol syndrome. This is a collection of behavioral and physical abnormalities that are associated with the presence of alcohol during fetal development. So in mothers who were drinking when they were pregnant, you see this consistent pattern of these abnormal features of the face and head. One of them is this low nasal bridge, so the nose here in between the eyes isn't very prominent. Another one is the indistinct philtrum. That's the groove between your nose and your upper lip. Now, some people have one that really stands out, some people don't, but it's pretty flat in people who have had fetal alcohol syndrome, but that's not diagnostic, right? If you're missing this part, this facial feature, that doesn't do it. It's really this whole spectrum of symptoms, of the behavioral abnormalities as well that you see, some mental retardation and et cetera, that are diagnostic of fetal alcohol syndrome. Finally, alcoholism is sort of seen as its own kind of dependent behavior separate from that of other drugs, although the process is exactly the same for addiction to alcohol as it is for addiction to any of the other drugs, including heroin and nicotine, etc. Alcoholics Anonymous is a group that we're going to talk about later in the semester. They view alcohol dependence as a disease. This disease model became popular in the 40s and 50s. The only treatment for the disease is to completely abstain, in the view of Alcoholics Anonymous. That dependence is the primary disease. It's not the result of some underlying cause. This has been criticized before, although a lot of people do subscribe to this model. If it is a disease, what's the cause? We're starting to understand that actually a little bit better now. Not all dependent drinkers exhibit exactly the same symptoms. It suggests that perhaps abstinence isn't the only answer for all drinkers, but that question remains to be answered. That's it for our talk on alcohol, and we will see you next time.